Alright guys, so these are those examples I had you try for the area equals half apothem times perimeter problem, so I'm going to do those with you real quick. Okay, so in this problem here, I do know my side length, so I can fill in perimeter a little bit. I don't know my apothem yet. So since the side length is 8, and there are 6 of them, we can call that 8 times 6. But because I don't know the apothem, we have to do that 360 divided by 6, because there are 6 sides, and then split in half again, making that top angle there 30 degrees. So I'm on a 30, 60, 90 triangle. The other thing that's always true is that your apothem bisects your side. So it cuts the angle in half and it cuts the side in half. So that means that this here is 4 centimeters. And that's good to have because it's the small side across from my 30, making my long leg root 3 times this much, so 4 root 3, and makes my hypotenuse 8, although I don't really need that. I really just need the apothem, which is the 4 root 3. So we got half times 4 root 3, my apothem, times 8 times 6. And you can take half wherever you want, so I'm going to take half of the 8 just because it's the biggest number. And then we got 4 times 4 times 6, which that's kind of big. So I'm going to grab my calculator. And we got 16 times 6 for 96 root 3 centimeters squared. Okay, same idea with the triangle down here. So we're going to do half apothem times perimeter. In this case, I know my apothem is 4, but I don't know my side length, but there are 3 of them, so we can fill in perimeter a little bit. So I'm going to draw on that radius. I'm going to do the 360 divided by 3, because there are 3 sides, and then split in half again, making this top angle 60 degrees. So on my 30, 60, 90 triangle, because that's what I'm in, I know that the short side is 4, making that long leg 4 root 3, oh my gosh, again, and then your hypotenuse 8, so that was an accident, but whatever, YOLO. So we got half times 4 my apothem times the side length, which isn't going to be simply 4 root 3 because I need the full side length, so 8 root 3 because it's always half or double depending on which way you're going. And then I'm going to take half the 8 again, so 4 times 4 times 3, so 16 times 3, so 48 root 3 centimeters squared is our area on that one. And then last but not least, for the easier ones, I could do in the square, I could extend out that diagonal because it would be the same on the other side and do half d1 times d2. But just to practice our apothem perimeter stuff, we got area equals half apothem times perimeter. And unfortunately, in this case, I don't know the apothem or the side length, but I'm going to replace p with side times 4 because there are 4 sides. Alright, so we always go back to that 360 divided by 4 because there are 4 sides, and then split in half again, making this top angle here 45 degrees, so we're on a 45, 45, 90 triangle. And on that 45, 45, 90, you know the hypotenuse, which is 11 root 2, making each side here 11, making the full length of your side 22, so you can do half your apothem, which is 11, times the side length, 22, times 4 sides. And then I can take half of whatever I want, so I'll take half of the 22 for 11. 11 times 11, we're at 121, and then times 4, so 484 centimeters squared for the area. Okay, so those are the ones we kind of hope for because 30, 60, 90, 45, 45, 90 are fast. These other ones here, we have to do trig, so they usually take a little longer. So for this example, find the area of a regular decagon with an apothem of 6. We can do half apothem times perimeter. So we know our apothem is 6, and to find perimeter, we're going to do 10 times however long the side is. And in this case, I told you guys, really the little mini right triangle that you draw in is the only thing that matters. And we have to find that top angle by doing that 360 divided by 10, because I have 10 sides. and then splitting that in half again. So our top angle is 18 degrees, so real teeny tiny. And I'm trying to find the side, which is always opposite of that. And then I know the apothem, which is adjacent to that. So I'm trying to find opposite. I have adjacent. The only trig function that uses that is tangent. So you're going to do tangent of 18 equals opposite, which I don't know, over hypotenuse, or over adjacent, excuse me, which is 6. And so because x is on top, I'm going to times by 6 to the other side. And so on my calculator now I have to do this. I'm going to take the tangent of 18. Ooh, I better turn off my little locky do. So on my calculator, I'm going to do 18 tangent and then times 6 for like 2-ish. Then I need to double that. So I'm going to just do that right now so I don't round. So times 2, because this is only part of the side, so I need the full side. And so my side length here is like 4-ish. But the thing is, I have this all written down, so I can kind of just do the rest of it. So I can times by 10, and then I can times by 6, and then I can take half, or I could just take half now, so times by 3, and get that the area is 116.97, or just 117, I guess, is probably a better approximation, feet squared. That's huge. Okay, and then last but not least over here, find the area of a regular octagon with a side length of 6, which when I draw that little right triangle in, the 6 gets bisected, so 3. But if we're thinking half apothem times perimeter, I can fill in some of this. I don't know the apothem. We can do perimeter by doing 6 times 8, because each side is 6 and there are 8 of them. And so I just have to find my top angle here, so that I can use sine, cosine, or tangent to find the apothem. So we're going to do that 360 divided by 8. And then split that in half again. Oof. 22.5. Oh yeah, did we do this one? Yeah, yuck. Okay. But because I have the opposite and I'm trying to find adjacent, again, I don't really care about that hypotenuse. We're just going to use tangent again. So tangent of 22.5 equals opposite, which is 3, over the adjacent, which is my apothem. And when x is under like that, we just do a little swapperoo. We did that before, right? Yes, we did. So x comes up, tangent goes under, and now I have to use my calculator to figure this out. So we'll do 3 divided by 22.5 tangent equals. So that is this 7.2 yucky number. Which is going to go in for my apothem. I don't need to double it because apothems aren't cut in half or anything. But to not round, to just keep the most appropriate answer, I'm going to take this, I'm going to times by 6, and then I'm going to times that by 8, and then I'm going to take half. So 173.8. I'm just going to double check that because I feel like I accidentally hit something weird. And then times 6 times 8, take half. Okay. Centimeters squared. Alright, so hopefully seeing me finish these ones out kind of helps you guys. You have a practice that goes with this, and then we'll have a review, and then we'll have a test later this week. Good luck!